What if, in the near future, environmental collapse makes Earth no longer habitable for humanity? Is there a second Earth somewhere close enough for us to escape to? Many scientists point to one prime candidate, Mars, a barren red planet just next door in our solar system. But today, Mars is a world where humans couldn't survive for even a single day. So the question is, could terraforming Mars, transforming it into a planet with blue skies and flowing water, ever be a realistic option? The first step in terraforming Mars is warming it up. On Mars, daytime temperatures can occasionally rise to around 68 degrees Fahrenheit, but at night they can plunge to minus 112 degrees Fahrenheit. This extreme temperature swing exists because Mars's atmosphere, although mostly made of carbon dioxide, is incredibly thin, only about 1% as dense as Earth's. As a result, it traps almost no heat. One proposed solution is to release iron or aluminum nanoparticles into the Martian atmosphere. These particles could absorb more sunlight, warming the planet and melting the carbon dioxide trapped in polar ice. As more CO2 enters the atmosphere, it would thicken, strengthening the greenhouse effect. Over time, frozen water on the surface could begin to melt, eventually forming rivers, lakes, and even oceans. But one critical problem remains unsolved: radiation. Long ago, Mars likely had a strong magnetic field similar to Earth's, generated by an active molten interior. As the planet cooled and volcanic activity ceased, that magnetic field disappeared. Without it, Mars is exposed to relentless solar wind and cosmic radiation, conditions deadly to any form of life on the surface. One of the most realistic solutions proposed so far comes from scientists at NASA's Goddard Space Flight Center. Their idea is to build an artificial magnetic shield. By placing a massive superconducting coil at the Sun-Mars L1 Lagrange point, it could generate a powerful dipole magnetic field strong enough to deflect solar wind. This artificial magnetosphere would envelop Mars, protecting its atmosphere from being stripped away and shielding the planet from harmful radiation. If an artificial magnetic field were established and Mars gained a stable atmosphere and liquid water, the final step would be introducing life. The most likely pioneers would be cyanobacteria. These microorganisms absorb carbon dioxide, release oxygen, and gradually transform barren soil into habitable terrain. Over thousands of years, cyanobacteria could slowly raise oxygen levels in the atmosphere, creating conditions where plants could grow. Eventually, forests, ecosystems, and environments capable of supporting human life might emerge. Still, the challenges are immense. Dispersing metal nanoparticles across an entire planet could take thousands of years. Creating an artificial magnetic field on a planetary scale is something humanity has never achieved before. And no one knows how long it would take to raise oxygen levels high enough for humans to breathe freely. That's why settling Mars wouldn't simply be about building cities. It would mean redesigning an entire planetary ecosystem from the ground up, an unprecedented challenge in human history. So the question remains, can Mars truly become humanity's second home?